once you finish your work in limits in a calculus course, the next thing you do is to look at the derivative. And we find the derivative of a function, if we're using the definition, by taking the limit as delta x approaches 0 of the difference quotient, f of x plus delta x minus f of x all over delta x. Now that formula gives us the slope of the tangent to a function at any given x value in the domain of the function if the derivative exists, if the tangent line to the function does exist at that point. And if you wanted to see how to find the derivative of a function using the definition of the derivative, I've linked a video that I've done working the process of several examples out using the definition of derivative in the description of this video. I will also link in the description of this video videos that go over how to find the derivative using the rules of differentiation. Now for this one specifically, once we know that the derivative of a function is the formula for the slope of a tangent line to a function at a given x value, well, the very next natural step then would be for us to be asked to write the equation of the line tangent to a function at a specific x value, or it could be even later on when we are asked to write the equation of a tangent line to a mathematical relation at an ordered pair point. In this video, what we're going to look at specifically is looking at writing the equation of a tangent to a function that is a pretty elementary function that we would be looking at and finding our derivative with our differentiation rules. But the main thing you want to take away from this is the overall outline and process to use, so that when you're further along with other types of differentiation rules, you're able still to answer the questions about writing the equation of a tangent line to those mathematical relations using this basic structure. So let's get started. Here it asks to write the equation of the line tangent to the function f of x equals 3x squared plus 5x minus 1 at x equal -2. Now remember, anytime you're to write the equation of a line, even way back in an introductory algebra class, there are a couple different ways to write the equation of a line, but for our work in this video, I'm going to look at writing the equation of the line using the point-slope form. So what occurs when we want to write an equation of a line is that we need the slope, a point, and then once we have the slope and a point, we then plug the information into y minus y sub 1 equals m times the quantity x minus x sub 1 into the point slope form. Now when we go through this process, we want to keep our thoughts also on how we wrote equations of lines and where we got information when we were working with courses prior to our calculus course. So for example, right into the value of the point that the function goes through where we want to write that equation of that tangent line. Well, the point in the problem says that my x-coordinate of my point is -2. Now, if I know an x value and I have the function that I'm working with, then to find the y-coordinate of the point, I just evaluate the function at that x. So to find the y-coordinate of my point where I have my equation tangent to that function, we're going to take and find f of -2, just like normal. -2 is the input, f of -2 is the output. So we're going to have 3 times -2 squared plus 5 times -2 and then minus 1. So then my f of -2, remember to do order of operations, so you're going to square the -2 before you multiply it by 3. So -2 squared is 4. 4 times 3 is 12. So I have 12 minus, then positive 5 times negative 2 is minus a 10, and then minus 1. So my f of negative 2 comes out to be 12 minus 10 is 2, minus 1 is 1. So that's the y coordinate of my point. And so I can already get started. This is your x sub 1 and this is your y sub 1 in my point slope form. So already I have y minus the y coordinate of my point, 1, is equal to, and then we're going to have our slope value in a minute, and then times x minus the x coordinate of my point is negative 2. So a lot of times I like to have my students get the y coordinate of the point before they go to find the slope, just so they remember that that's how we did it before we hit this topic, so that's how we still do it. Now next up is, what about the slope? So if you remember back to your algebra classes, the slope sometimes they would hide in different ways. Like they might ask me to write the equation of a line through 2 points, in which case I would have to find the slope from the change in y's over the change in x's. So we would do y sub 2 minus y sub 1 over x sub 2 minus x sub 1, get our slope for there. Sometimes they would tell us that our line is parallel to another line. So we would need to find that other line's slope and then use that for our slope. Or maybe they told us that our line is perpendicular to another line. So we would find that line's slope, take the opposite and sign in reciprocal, and use that for our slope. But here, they're telling us that our line needs to be tangent to this curve at that x value. Well, that's what the derivative gives us. The derivative gives us the slope, a formula, so that if you put an x value in that you're interested in finding your slope of your tangent at, through the derivative, what you get out is the slope of the tangent line there. So for this slope process with this sort of a question, I need to find the derivative of that function. And the derivative of this function f, we denote f prime of x for one of our types of notations. There's several, but that's the one we'll use here. And then look at, this is 3 different terms, and for derivatives I can do term by term differentiation. Using the rules of derivatives, if I have a constant times a function, then the derivative is the constant times the derivative of the function. And when I have a letter base to a number power, I bring down the exponent, multiply it to the coefficient that's in front of it, keep the base, and subtract 1 from the exponent. So for the derivative of 3x squared, that is going to be 6x to the first power. And then the derivative of 5x, well, the derivative of x to the first is just 1. And so 5 times 1 would give me a derivative of 5, so that's plus 5. And then the derivative of a constant term is 0. So the derivative of this term, negative 1, is just 0. So my derivative of f of x equals 3x squared plus 5x minus 1 is f prime of x is equal to 6x plus 5. This is the formula that output is the slope of the tangent to this function at any given x value that's in the domain of the function in which that derivative exists. I want to know the slope of the tangent to this function at x equaled negative 2. So to find the slope, I will take the derivative and I will evaluate it at negative 2. So that's 6 times negative 2 and then plus 5. So my derivative evaluated at negative 2, well, that's negative 12 plus 5, which is negative 7. And that's the slope of the tangent at negative 2. And so that's what I have as my slope. And now I can come down to my point slope form and I can put our negative 7 slope in for the m. And then all I need to do is to rewrite this equation to put it in the final form to report it. So this is y minus 1 is equal to negative 7 times x, and then minus the negative is plus 2. So then negative 7x minus 14 when I distribute the negative 7. So I have y minus 1 is equal to negative 7x minus 14. And then add the 1 over, we get y is equal to negative 7x minus 13. So that's the equation of the line tangent to this function at x equal negative 2.